Yes, good afternoon, everyone. A warm welcome to today's session, Conservation Agriculture Series. This is brought to you by Share Screen Africa in partnership with Rwanda Polytechnic, Musanze College. We have their students in the room, but this is a series that is open to other public audience who are interested in conservation agriculture. My name is Diane Mumararungu. I work with Share Screen Africa as the project lead under Conservation Agriculture Projects. So I'm going to be your host and the moderator for today's session. And thank you for joining us once again on this deeply insightful conversation we are going to have. The talk is going to be centered around the critical and timely theme of the science of soil health and building a strong foundation. And to whoever is joining us, feel free to use the chat box and tell us where your name, where you're joining us from, the country, and the organization that you work from. It would be a pleasure for us to know you, your name, your country, and the institution that you work for in the chat box. So moving forward, I want us to, before we dive into the topic, let's look at the key learning outcomes for this session. So as I was saying, let's look at the learning outcomes for today's session. The science of soil health and building a strong foundation. The first is understanding the core function of the healthy soil, recognize the characteristics of soil health, learn the science behind building a soil health, identify effective soil health practices, and utilizing visual indicators to assess soil health. So, we are very privileged and honored to be joined by the leading voice in the field of conservation agriculture, Dr. Kofi Boa, the director of Center for Multi-Range Agriculture in Ghana. Dr. Kofi Boa has spent decades championing conservation agriculture across Africa, and today he will be helping us to unpack the science and the strategy behind the healthy soil and the lasting productivity. Without that, let me officially welcome him as he gives his talk to us. Dr. Kofi Boa, you can unmute your microphone as I share your PowerPoint.
Thank you very much, Dan, and good afternoon to everybody. I'm very happy to be on this call, and today we're going to be looking at soil health. So, before anything at all, we need to appreciate the fact that the soil is so basic for every farmer. And therefore, we have to take very good care of the soil. In other words, we need to nurture it in a way that we need to nurture the soil in a way that we can improve it, conserve it, and sustain its use. So, before I even start this lecture, what I want to do is to give you a quote from the Sanskrit scripture dated 1500 BC. And it says, upon this handful of soil, our survival depends. Nurture it, and it will give us food, fuel, and shelter, and surround us with beauty. Abuse it, and the soil will collapse and fall. Die, taking humanity with it. This simple quotation tells you that the soil is so important, and that if we do not do whatever it takes to keep it healthy, it will die. And when it dies, it will take you and I away. So for you and I to continue living, we have to make sure that we keep the health status of the soil intact. This afternoon, I speak on the science of soil health and building a strong foundation. And with this quote setting the stage, What at all then is soil health? So we begin to look at the soil health and how we define it. So the soil health is the capacity of the soil to continue to function as a living system. We are not talking about the soil health as the capacity of the soil to function, but we are talking about the capacity of the soil to continue to function as a living system. To do what? To sustain plant and animal productivity, maintain and enhance air and water quality, therefore having implications on the environment, and promote plant and animal health. Now, as we do this, we have to understand that the soil has some properties. And so from here, we'll be looking at some of the characteristics of a healthy soil. And looking at it from here, what we are seeing is the soil has a lot of characteristics. Now, a healthy soil should have very stable structure so that it stays intact, cannot move easily from point A to another point. It should have sufficient depth for rooting, which is very, very important, because down the line, we're going to see how plants also impact on soil health. And it should have free drainage, internal drainage, so air and water can easily circulate in there. So put together, these are some of the physical characteristics of the soil. But then the soil does not just have only physical characteristics. The soil also has chemical characteristics. And at this point, what we are looking at is a healthy soil should have sufficient but not excessive supply of nutrients. And what this implies is that a healthy soil should not require higher doses of inputs to produce higher yields. And so in this scenario, what you see is that we are talking about the chemical properties of the soil, the chemical characteristics of the soil. And down the line, the soil is also laden with a lot of organisms, live in the soil. And that brings about the issue of biology, soil biology. And so what we are seeing from here is that the soil has physical, chemical, and biological properties. And the healthy soil should have a very good balance of all these three sets of characteristics. In other words, a healthy soil should have a very good balance of the physical, chemical, and biological properties. It's not a case of talking about fertile soil where a lot of people will just refer to the chemistry, the amount of chemicals in there, the nutrients in there. It's got a healthy soil, has to have a good balance of these properties. And so at this point, we'll then go into building a healthy soil, a little bit about the science. And we're just going to restrict ourselves to basic science. In the first place, if the soil is not there, you cannot talk about its health status. And so what really happens here is that we have to find a way of keeping the soil in place. The soil has to be kept in place. And how does this happen in nature? Naturally, on the farmlands, soil will move from one end to the other through runoff or wind blowing it away. But then this is where the little bit of science comes in. Raindrops come from the top, travel several miles, kilometers, and hit the soil surface. And when that happens, it causes the disintegration of the soil particles. And when these soil particles get completely disintegrated, then they become so loose. And as it becomes so loose, then it is so vulnerable to being washed away. And when these particles are being washed away, what you see is that the soil, that is the soil, being washed away from the point of action. Now, this is what happens on an unhealthy soil. And an unhealthy soil is a bare soil. But on a healthy soil that is covered, the cover coming from mulch or from the crop canopy completely dissipates the kinetic energy of the raindrops. And therefore, it is not hitting the soil directly. This cover on the soil surface reduces the kinetic energy to the extent that rain water then gets into the soil gently. And therefore, it's not able to cause any disintegration of the soil particles. And so when the soil particles are not disintegrated, they are in the aggregated form and they resist movement. And therefore, the soil will stay in place. The other thing is, on the sick soil, in an unhealthy soil, when there is detachment of soil particles, they come loose and they block the micropores. And when the micropores are blocked, then water cannot go in. And so all you see is excessive runoff. And anytime you see the water running on the soil surface, being dirty, convince yourself that it is the soil that is being moved away. And so the idea behind it is the soil being able to dissipate the kinetic energy by having a cover on it, which would then reduce detachment of soil particles and therefore causing it to resist being blown away by the wind or being blown away or being moved away together with runoff. Now, the soil also has structure. And if you go back to the very last slide, we talked about a healthy soil having a very good, stable structure, which is very, very important. And now, a whole lot of things are happening. We talk about, in conservation agriculture, we're talking about diversity of plant species. And what you really see is that some of these plant species, they have tap roots that will break the compacted layer to allow air and water to go in. More importantly, there are several of these that also have fibrous roots, and they enmesh the roots and mesh the soil particles to the extent that there is so much of the soil it's like weaving the soil. So if you remove a sort of grass, you see how the soil particles are put together by the roots. And this is where we are helping to the soil structure gets built. Similarly, and additionally, during the process of decomposition, there are several chemicals that are released, exudates in there. And several of these exudates are mucilaginous. They're like mucilage. And those ones also help to bind the soil particles together, thereby improving the soil structure to the extent that it resists movement. Now, moderation of soil temperature. What is happening is that there is life in the soil, as we're going to see. And several times it's so difficult for us to appreciate life in the soil organisms. Several of them are microscopic, we do not see. But our good old friend, the earthworm, is so visible and we see it. But you take a look at the earthworm. Look at the skin, it's so leathery, and therefore it doesn't tolerate escalated temperatures. So it's got to live in a medium, in a healthy soil that has moderated temperature. Now, what happens? Organic material on the surface serves as an insulator. And what we have to understand is that when this cover on the ground absorbs the heat is not readily transferred to the soil to heat the temperature. And therefore, the soil temperature is moderated to the extent that these soil organisms are at home. They are so healthy and they constitute life in the soil. And a healthy soil should be laden with a variety of soil microorganisms, microorganisms. And so the fact that organic material is a very poor conductor of heat guarantees the moderation of soil temperature, which ensures retention of moisture in the soil to some extent, as we will see very soon. And then at the same time, also ensuring that these soil organisms, once they are in there, they are at home. We talk about moisture, which is so important in all that we discuss. Now, every healthy soil should be able to hold water to the full capacity. And that is where then we say that this soil is so healthy, it's able to hold water for the use by plants and whatever life there is in the soil. Now, an unhealthy soil cannot conserve moisture in itself. When you have a healthy soil, what happens is that because of the fact that the healthy soil is covered with organic material, which reduces the speed of runoff, that creates condition for water to go vertically in the soil rather than run off to cause erosion. So in an unhealthy soil, micropores are blocked, it's crusted, and so you don't get that much water getting into the soil. And so because of enhanced infiltration, which is a good characteristic of a healthy soil, there is, after rain, there is a good amount of moisture getting in there and being retained for use by our crops. The other side of it is the prevention of evaporation. And here we go into a little bit of physical science, physics. We all know that the soil has, the water has a very high specific heat. And so if there is a lot of soil stored, a lot of moisture stored in the soil, it will require heavy amount of energy, heat, to cause that water to move from the liquid phase to the gaseous phase. In other words, to evaporate a molecule of water, it needs so much heat, so much energy. And so, coming from the top, when we're seeing enhanced infiltration, ensuring that there is a good amount of moisture in the soil, conserved in the soil after rain, it tells you that to get that water in the soil to evaporate, you need so much energy, coming from the fact that water has a very high specific heat. But on the other hand, in an unhealthy soil, in a situation where you have so much runoff and there is very little water stored in the soil, it gets heated up easily and it evaporates. A good scenario is if you have a cup, a teacup of water, and you are boiling it, as against when you have a big barrel of water and you're boiling it. It takes so little energy, so little heat to boil the cup of water. But when you want to bring a barrel full of water to boiling point where water can evaporate, you need a lot of time, you need a lot of energy. And this is what confers on the rich moisture content of healthy soils. Yes, so it becomes very interesting as we continue looking at the basic science of soil health. We talked about increased fertility. And see, this is where the health status of the soil, as we are emphasizing now, comes differently from the earlier times when agronomists, scientists, all our concern was on fertility, fertility, fertility. And for most of the earlier scientists, fertility had to do with just the nutrients in the soil. But that is not all. A healthy soil, like I said, has a balance, a good balance of the physical, chemical, and biological properties. So it's not just the nutrients which confers on it, the physical nature of, the chemical nature of the soil, that is the key. Now, organic matter in the soil serves as a nutrient sink. It's laden with nutrients, and every plant that you see thriving on the soil surface has a lot of nutrients in it. And so our contention of the fact that we allow this organic matter to stay on the healthy soil then tells us that this is a system where we are having a storehouse of nutrients embedded in the soil to be released gradually. And then also here we talk about the organic material enriched with humus. And what really happens is that this is where we enter into the chemistry of the nutrient dynamics in the soil. Talking about cation exchange capacity. These colloidal particles, together with the humus, have negative charges. And these negative charges have a good affinity for the positive ions, that is the cations in the soil. And so they are able to absorb the cations in the soil, of which in the soil solution, which would have fallen victim to leaching. And so one who have these absorption sites attracting the cations, then what really happens is that they get absorbed and then have the potential of being released gradually into the soil environment for use by our crops. And this is where it resists leaching of several of these nutrients. And so the cation exchange capacity, as well as the organic matter, it's serving as a sink of nutrients coming from the green plant, and which then comes into the soil to be decomposed. So a healthy soil has a very high cation exchange capacity. And what has happened is that these days, fertilizer manufacturers are trying to mimic this by, for instance, on the market, you can get a nitrogen fertilizer coated with urease inhibitors. And all that they are doing is ensuring that when you apply that, the nutrients, the nitrogen, nitrate does not come readily in there, part of which will be absorbed by the plant and the greater part leached out. And so now science is actually mimicking what really happens in nature, in the soil, when we have a healthy soil. Then, of course, life in the soil, which is so interesting. But then we are looking at the organic matter as a food source for soil organisms. We just came through as organic matter serving as a sink of nutrients. It is the food source for soil organisms. And therefore, if soil organisms have to thrive, and if the high amount of of soil organisms in the soil is a good indicator of a healthy soil, then what we are saying is that that soil definitely should have a high amount of organic matter to sustain life in the soil. Now, what happens when there is this much food for soil organisms in the soil and they are actively going up and down? That is where they create the channels for enhanced infiltration, for enhanced aeration. And as they keep going up and down, that is where they are also helping to mix the soil, and therefore we do not get that stratification of nutrients as a lot of people contend. But the interesting part has to do with the role of the plant in terms of soil health burden. And what we are emphasizing is that the soil, a healthy soil, has to have living plants on it 365 days of the year. The idea is that the plant feeds the soil through photosynthesis, through the roots. And here we go a little back into the earlier physiologists who contended that photosynthesis was very inefficient. And this contention came as a result of the fact that for like about 100% of whatever the plant produces through photosynthesis, it uses only 60%, and that the 40% was considered a loss. And that was universally accepted by crop physiologists. Little did we know that photosynthesis was so efficient, and that it is not just a way of seeing the outlook of the plant, but then it is a way of also ensuring that there is a high level of soil activity, microbial activity in the soil. And what happens is that this 40%, which was considered to be a loss, now current science has taught us that it is rather translocated. It goes through the roots to feed the soil organisms. And at the root tip, that is at the rhizosphere, looking deep into the science of rhizophagy, what really happens is that this amount, this 40%, which is lost, is rather what comes out at the root tip as the exudate to feed the diverse microorganisms. And this is what we call the liquid carbon. And so the 40% that everybody was considering to be a loss is really an asset for the soil in terms of burden itself, ensuring that it has diverse, large quantities of diverse soil organisms. And this is where conservation agriculture will tell you that we need a diversified crop species, because several times diversity, all the time, diversity above ground corresponds to diversity below ground, because there are specific plants that have specific microorganisms. And so when you have a diversified crop species on the field, you're also ensuring that you have diversified soil organisms in the soil in there. And that confers on the soil all the biological properties which reflect in the plants. And the soil microbiome has also been linked to the gut microbiome of us and animals that depend on the plants. And so put together, what we have talked about just now tells us that, yes, the soil has, a good soil should have a balance of physical, chemical, and biological properties. And this short discussion of the basics around the science of soil health gets us to appreciate a little bit of what really happens to keep the soil healthy. Now, the other thing to know is that we have to ensure that the soil we build healthy soil. Now, for all that we have spoken about, there are certain things that farmers, you and I on this call, have to do to ensure that we enhance the health status of the soil. And so, as farmers, there are several times we do a lot on the field. But what we have to understand is that whatever we do on the field should enhance soil health. So all good soil health management practices should have certain requirements. And so, looking at this, whatever you get up to do on the farm should ensure that you are meeting these requirements. And so I have repeatedly told farmers that as a farmer, before you get out from bed in the morning, ask yourself a simple question. And that question should be, what is it that I am going to do on my farm today? And is that going to enhance soil health? And so if what you're going to do as a farmer on the farm today does not meet any of these requirements, does not meet most of these requirements, then please continue to sleep, have your body, and stop destroying our soils for us. And so a good soil health management should maintain active biological life. We have seen it from the previous slides. If what you're going to do on the farm today as a practice is not going to maintain active biological life, stop it. A good health soil management practice should be able to control erosion sufficiently. The soil has to be in place. It doesn't have to move from where it is so that we can nurture it, improve it, conserve it, and sustain its productivity to sustain human life. This is so important, and to give us all the ecosystem services that come with it. And so, whatever you're going to do on the soil, on the farm today, should be able to control erosion sufficiently. And by that, you are enhancing soil health. Organic matter is so much important. And so the work that you're going to do on the farm today should be able to maintain adequate levels of organic matter on and in the soil. Maintenance of soil physical properties. We are not just talking about chemistry in terms of nutrients in the soil. The soil has physical properties. We saw from our previous discussion, talking about the structure, talking about drainage and all that. Those are made possible by having very good soil physical properties. And that is why conservation agriculture is so emphatic about cessation of plowing, which breaks the soil apart, which disintegrates the soil structure and therefore ruin it of its adequate structural stability. Moving on, we're talking about whatever you're going to do on the soil, on the farm today, should be able to maintain appropriate levels of nutrients in the soil, such that, as we said earlier, you will not require heavy inputs in terms of soil amendments to be able to produce a unit output of the crop. Better still, moisture is so much important. And the question you ask yourself is, what am I going to do on the farm today? Is it going to conserve soil moisture? If it is going to deplete soil moisture, if it is going to ensure that water does not go into the soil, please continue to sleep in bed. Rest your soul. And at the end of the day, go hungry forever and ever. Now, temperature is so important. Where we talk about the specific heat of water and all other things causing evaporation, causing us to lose water, and more importantly, how it impacts on soil life, the soil organisms, and our good friend earthworm used as an example. So, once again, what I'm saying is that as a farmer, before you go to the farm on any given day, ask yourself that simple question. And if whatever you're going to do on the farm is not meeting any of these requirements, then please think twice. But then, what are we saying here? What we are talking about is that these are good soil health requirements. But then, what is it that as a farmer you do on the farm physically to ensure that all these processes, all these requirements are met? And so once you get up there, whatever you do should ensure that all these requirements are there. And so what are some of the specific practices that we do on the farm to ensure that we have the majority of these practices, majority of these requirements in place? And this is where it becomes so nice when you are in dialogue with farmers, especially farmers that have been exposed to conservation agriculture. There is so much that they talk about. And so let us look at some of these. Diversification. Diversification of what? Diversification of plant species. This is very critical when we talk about conservation agriculture. And that is why conservation agriculture never ever subscribes to monocropping. Because from our previous discussion, looking at the basic science, we saw how diversified cropping species impact on diversified range of soil organisms, and each of them with unique attributes coming together, enhancing soil health. So multiple cropping. Here, we talk about mixed cropping or intercropping. And so when you have multiple cropping, it's not just a matter of ensuring that farmers have a varied diet. Fine, that is good, and that is what we need. That is a requirement. The nutritionist tells us that we should have a variety of things. But in the soil, this is so important because, as we said earlier in our discussion, talking about photosynthesis and the fact that the liquid carbon is feeding different soil organisms in there, and each soil organism coming with a different benefit to the soil environment, the rhizosphere. This then tells us that as much as possible, for diversity and for the value of diversity in the soil environment, which then confers on the system biological controls, having a diversified cross species is so important. And we can have that through planting a different mix of crops, either planting them in associations or one doing the crop rotation, one after the other, being mindful of the fact that we do not have come with the same species of crops after the other. And then also looking at agroforestry, which is also a way of ensuring that we have diversity in the plant, in the environment. So as we continue to talk about this, we're looking at other processes, soil management. There are several things that we can do to ensure that these practices are in place. Cover crops, very, very important. Helping us to continue to cover the soil and talking about the fact that we need 365 days of cover. This brings in the aspect of just towards the second half, just after the second half of our main crop, we can relay compatible cover crops into the cropping system such that when our main crop is harvested, the cover crop, which when established, most of these when established, have internal resistance to stresses, are able to cover the ground and extend the green cover deep into the dry season, which then helps us to sequester a lot more carbon in the soil and continue to feed the soil organisms for a longer period. Soil management, manure, talking about mulching, talking about compost application, as well as doing very little disturbance to the soil to be able to grow a crop. And so as we keep talking about all these processes, the three main principles of conservation agriculture keeps resounding. Doing very minimal disturbance to the soil, ensuring that we have cover on the soil for as long as possible, and then also ensuring diversity of plant species. And then talking about the fact that we need to keep the soil in place, because if the soil is not there, all that we're talking about comes to nothing. Now, on hilly environments like we have here in Rwanda, ensuring that we are able to delineate the contours and farm in such a way that we are not enhancing soil movement through enhanced runoff, means that we have to be able to determine the contours and plant across the slope. And having delineated the contours to that extent, we then institute barriers, which could be the grass barriers, living barriers, and in places, several places in Africa where we have animals, when these contours are stabilized with vegetative living barriers, such as the grass strips, we could then be harvesting the grass to feed the animals and then bringing their droppings to the farm. Purely ecological. The use of trash lines, looking at check dams and tide ridging, all put together ensures that with diversification, good soil management, and conserving the soil, we are able to keep it in place. We are able to improve it, uphold its health for sustainable use by you and I. And so, as we continue with our dialogue, as a farmer, doing all these things, how do you guarantee that your soil is healthy? And so there should be a way of the ordinary farmer, the smallholder farmer who works within limitations of resources, to be able to ensure that, yes, now I'm happy, my soil is getting healthy. And so we take a look at some visual indicators of soil health. And the visual indicators are, sorry, now it's coming. As a farmer, most of the time, looking at the plants growing on the land, you are looking at the dark green plant color. That for us smallholder farmers without sophisticated gadgets to be able to go do deep analysis and all that, we are able to tell. And that guides us as to the practices that we are employing, giving us these plants with this deep green color tells us that, yes, we are enhancing soil health, and that is what to do. Vigorous plant growth. I mean, when we are there on the farm and our plants are growing vigorously, that is an indication that our soils are healthy. Come to think of the situation where after rain, well, when it has rained, but if we are looking at a situation where shortly after rainfall, even with that little drizzle, there is so much of ponding, then it tells us something is wrong. Our soil is not healthy because it is not holding as much water as it should be. Indicators of life in the soil. We do not have the microscopes. Smallholder farmers do not have the means of even assessing soil analysis, employing the services of experts to dig soil to find out what is there, looking at microbial biomass and all that. But so long as our eyes are open, our good old friend earthworm then becomes a very good indicator of a healthy soil. So looking at how many of these earthworms per unit area we have, looking at the wormholes in the soil, and then the worm cast, all of that put together tells us that our soil is healthy. What about if you pull a plant from your soil and from your farm, and the roots are going way down? The tap root is there, it's not bending. It tells you, the farmer, without any deep science, that yes, your soil is getting healthy. Then, of course, you're looking at the color, and all of us, when we were little kids in the primary school, anytime they tell us to go bring soil to school for flower pots, our teachers are telling us, go get black soil. So let us be happy that at least we have black being a symbol of a good thing, the dark soil color. And so from this, what you see is that irrespective of the availability of expensive soil analysis or gadgets, the farmer is able to tell that the soil is healthy. Now, fungi, hyphae, and all that, good soil structure, all of that. So when we have understood the basics of soil health, looking at the physical, chemical, biological properties, and the fact that there's a bit of science in the manifestation of all this, putting all that together and ensuring that whatever we do on our farm on any given day enhances soil health, we then should come to a point where burden a good soil health will free us from misery. As you see here, my good brother, not so happy because of farming on an unhealthy soil. But if we commit ourselves to burden a soil that is so healthy, we will definitely go from misery to happiness. And this is the ultimate goal. Being so happy with ourselves because we have ensured that we have a healthy soil. We're enjoying the fruits of we contributing to ensuring that our soils are healthy. So healthy soils will move us from misery to happiness. Thank you very much for your patience. Thank you.
Thank you so much, Dr. Kofi Boa. I really want to take this time and appreciate your time and expertise to go under this detailed presentation that we just had. And thank you so much for your time and expertise to share with us. And I think from everyone else, what we had, soil is just more than the dirty beneath under our feet, but it's a healthy system that would help us to have food security and sustainable agriculture. So now we are moving on to a Q&A session. Remember, we are Phoebe remaining with a few minutes. So I want to ask whoever who is having a question, please use the reaction button and raise your hand so you can ask your question to our expert, Dr. Kofi Boa. Or drop your question in the chat box. I can see Claire Van Lithem has already dropped a question in the chat box. If you don't mind, please unmute yourself and ask the question.
Hi, hello. Thanks, everybody. Thanks, Professor Boa. I really appreciated your talk. I was wondering about what you thought would be the best way to start with a piece of land that is currently covered with grasses. So the grasses have obviously their own root structure and they've pushed out a lot of the other plant diversity. So I'm not sure what the soil quality is underneath. So would you suggest to start with looking at soil structure? So obviously it depends on whether it's a clay or a loam type soil. And yeah, whether there's ever a point at which tilling would be advised at the start of starting to sort of change the use of a piece of land that has grass on to an agricultural use in terms of, maintaining the health of the soil whilst one is changing over from grass to agriculture.
Yeah, thank you very much. This is very, very important, and thank you for bringing it out. And it's not just on the grass. So all that we're saying is that conservation agriculture, regenerative conservation agriculture, so good. But then, I mean, what are the conditions? What are the conducive conditions for you to see the value? And like she's talking about, she's saying, if you are starting on a piece of land that has a limitation, that has a problem, ensure that you are able to do away with that before you start. In other words, in the situation that she's talking about, if it is this much of a problem, the question you ask yourself is, how do I get an entry? How do I start? And no matter the value of conservation agriculture, if you are starting on a wrong footing, you're not going to get it right. And so on the crusted soil, the very first thing is to ensure you're able to break the crust. And this you can do by either using the ripper or in the very first instant, ensure that you're able to work the soil to ensure that you'll be able to put something there, but then that is a pathway for you to start. So if you have a field that is full of grass, which is unmanageable, do whatever there is to ensure that we're able to cut the grass, we're able to open the soil. And from that time on, you stay away. The point is that no matter how valuable all these conservation practices are, the starting point is very critical. And so whatever you do should aim at preparing good grounds for the initiation of conservation agriculture. And so I will say, and it is a fact, we have seen it and done it several places, let us eliminate the limiting factor. Now, crusted soil, soil full of grass, wanting to institute CA immediately, let us remove the grass by whatever means and make sure we break the soil and start from there.
Thank you. Thank you, Dr. Kofi Boa again. I hope, Claire, you've been answered. Now I can receive one more question. If you have a question from the audience, feel free to raise your hand and unmute your microphone to say a question. If not, I would like, Dr. Kofi Boa, I would like to take a chance and ask my question that I had. Would you explain to us about soil biology and how it contributes to improving the productivity.
Good, see. Very interesting. Soil biology, the very first thing you have to understand is there is life in the soil. And there is a diverse range of soil organisms in the soil. And several of these have specific roles. And all those roles put together ensures that the soil is healthy. And when you have a healthy soil, it becomes productive. This is why I keep repeating myself anytime I talk, that as much as possible, we should have a diversified cropping system. Diversified cropping system ensures diversity in the soil. Now, look at what is happening. Bacteria does what? The fungi does what? If you have mycorrhizal fungi, it attaches its roots to itself to the roots at the rhizosphere and extend the rooting volume further away to bring in what? Nutrients, to bring in water. And that is why when you have side by side a plowed field and a CA field laden with soil organisms, after rain, 2-3 weeks, when the plowed field is, the crops are wilting, the one on the other side on the CA field doing what? Not the least of wilting. What is happening? It's not being watered, and this one is also not being watered. It is this soil microbiome. And so if the plant is supplied with nutrients and water, it will grow. And as it is growing, it tells you, and I said that let the farmer look at the color, the robustness of plants there. And that alone confers on the farmer the visual appraisal of a healthy soil. And so that is why it is so important not to be digging the soil, plowing it, and destabilizing the habitat of the soil organisms. Not to be plowing it, mixing the organic matter, which is the source of food for the soil organisms, because the very moment you plow it, you turn it, and it mixes to the soil organisms. The interface, what happens is that there is enhanced mineralization. And when you have enhanced mineralization, there's a burst of nutrients in the soil, and the plant might not be able to cope with it in the sense of siphoning everything at once, and the bulk of it leaches out. And if you have something like phosphorus, when the plant is not able to take it immediately, it gets tired. And that is why in African soils, you can do the analysis. You have so much phosphorus, but then the bulk of it is not in the available form. So life in the soil coming from the diversified soil organisms in there is so important in moderating several of the processes in the soil, the physical processes, physical properties. We're talking about something like mucilage, where the bulk of that comes from the activity of the soil organisms. The soil organisms are moving in and out. And what happens? As they move in and out, they create micropores, which then enhances air and water into the soil. And so the soil organisms confer on the soil biology, in effect, is superior when it comes to all these processes because it moderates the physical and the chemical properties. And that is why conservation agriculture lays a lot of emphasis on soil health, which in effect has a lot to do with keeping alive the soil organisms there.
Yes, thank you so much, Dr. Kofi Boa. That was well detailed explained. I appreciate. And I want to see if we have more question. I think we have a question from Lichard Mazabedi. Please free to unmute your microphone and ask your question. And this will be our last question so that we can close. Yeah.
Thank you, Prof. That was a very insightful presentation. So I'm asking for my own environment here, which is arid. So do you think climate change effects like extreme heat will maybe reduce the biodiversity of microbes in the soil? And for small-scale farmers, what would you recommend as mitigation measures? Thank you.
Thank you very much. Yes, extreme heat definitely can have serious effect on the soil microbiome as we talk about. But then, fortunately for us, you see, we have several of these conservation practices. It becomes very difficult for us in the very arid areas to be able to cover vast areas of land with mulch. And there are, of course, there are several instances where for the greater part of the year, even being able to raise a crop becomes a problem. And this is where we look at the fact that these sustainable production systems like conservation agriculture is very much context specific. So what we do to conserve soil and water in the humid parts, what we do to conserve soil and water on the flat land, what we do to conserve water in arid environments might not be the same as we do in all the other areas. But the ultimate will be to be able to conserve soil and water for use by the crop. And so in the arid areas to start with, we have these processes of, and we know it doesn't come easily. It takes a little bit of time in set conditions to be able to stabilize the system. But then the little amount of organic material that we have, we should be able to concentrate that on small portions of the land. For instance, doing the zai pits, doing the half moons, and ensuring that we are able to do even the zonal tillage, concentrating the little amount of material that we have in these pits will enable us to ensure that that microenvironment is improved. And that, in a way, will influence how much we're able to build in terms of vegetation, in terms of crop biomass, which will reflect on the yield. And then as we keep burden biomass in these micro catchments, these pits, this half moon, we then begin to have a lot more of material to gradually extend to the bare lands. And so in such environments, unlike the humid parts, the speed upscaling will not be as fast as you can get in an environment like what we are experiencing here in the humid part. But then all that happens is that we have a unique opportunity, conserving the little amount of moisture, conserving the little amount of organic resources in small environments, improving that, and burden heavy biomass, which then gradually we are able to extend. And more importantly, integrating some of these cover crops that have some resistance to stresses. We talk about several of these. Tepper bean, for instance, is edible. It is a bean that is so much suited to the dryland areas. In fact, it's a desert bean. And so this is where to start from, improving the micro catchments and gradually bringing in stress-resistant species. We then will be able to expand gradually, and with time, we'll change the environment.
Yes, thank you once again, Dr. Kofi Boa, and elated for your question. So we are now towards the end, and I want us to come back to the key learning outcomes that we started with. But I want to appreciate everyone that will join us this afternoon. I want to also give a really thank and appreciation to Dr. Kofi Boa for taking his time and to share with us his expertise on soil health and the foundation of of building a foundation for soil health. So I want to thank everyone for who joined us, and thank you, Marit, who is sharing with us the key learning outcomes that we started with. And I'm so sure that Kofi Boa passed through each and every point and gave detailed explanation. And to the audience, we're asking to share the recording. I've shared with you the link to our website in the chat box. That's where you can find the recording. And we also have a YouTube channel where we do put content similar to this. So without further ado, thank you, Dr. Kofi Boa. I don't know if you have last words for us as a concluding remarks, so we can close and
Well, I thank you for making it possible for me to be on this call. And as it has always been, I'm always ready, so long as my time permits, to share knowledge and experience with all of us. And it is my hope that we will commit ourselves to building healthy soils all around. Well, I thank you very much for putting me on the call. And my hope is that all of us will work together as we advance soil health burden and continue to share knowledge amongst ourselves. I mean, knowledge keeping to ourselves will mean nothing, because we are in a global crisis, and to come around this crisis, we have to continue to develop ourselves and continue to share whatever we come through to be the state of the art thing. So I thank everybody for your time, and thank you very much for getting me on the call. It will be a big pleasure to me if we all commit ourselves to building a healthy soil.
Thank you so much, Dr. Kofi Boa. And we are now to the end of our session. Thank you for being here with us.